All right, so we're going to continue on yesterday's lesson. So if you are on the video, all you really need to do is write down day 170 and then just put scatter plots and trend lines day 2. Take a moment, pause the video, and write this down. Okay, good. And we're going to move on. So we're going to continue on with our discussion from yesterday. We're going to ask ourselves, are two things related to each other? Okay, so we could ask anything. Let's see. Is the number of miles someone runs every day related to how much they weigh?
No. Could be.
Yeah.
Yeah. Could be because if you run.
Well, what if you're like a really tall like NFL player that runs every day, but is like also really heavy?
Like a linebacker.
And let's say you're really like a young girl that doesn't run at all and is really light.
Then you run.
You see what I mean? So it's all about how you ask the question, right? But we could ask ourselves if two things are related. We talked about the shoe size yesterday. Is shoe size related to speed? How fast you run?
No. Not necessarily.
Generally it is, right? But it's not really closely related, right? Is engine size related to how many miles per gallon you get? Yeah, we can make that assumption. Okay, and today we're going to mathematically see how strongly that's related to one another, okay? So these are the steps, and we're going to be using Desmos to work this out. I'll be showing you how to do this on Desmos, but the answers that we're really looking for is we're looking for the line of best fit, which is going to be, oh, and by the way, this is not supposed to be an equal sign. I made a mistake here. This is supposed to be Y1 tilde. That's a tilde there. Okay, change that. Tilde, is that tilde? Tilde. Really strong vowels all the time. Okay. When we put that into Desmos, it'll actually do a regression for us, and then it'll create a new line of best fit that's perfect, okay, and it'll give us a slope and y-intercept. And then the R value, which is R, this is super important. And basically the idea is you have two numbers. You have -1 and 1, and you actually got three numbers, and 0. The closer this number is to 1, the stronger it is to being positively correlated. The closer it is to 0, the less strong it gets, and the farther away from 0 to -1 it gets, it becomes really strong indirect relationship. Does that make sense? So the R value is always between -1 and 1. The closer it gets to the middle, the less strong it gets. Does that make sense? So for example, the number of hours you study a night related to the number of snacks you eat.
No.
Not at all, right? I could say, how many hours did you study last night? And you could be like, oh, 0. How many snacks did you have?
A lot.
Be specific.
Like 20.
20. And how many hours did you study last night?
Huh?
How many hours did you study?
0.
0. How many snacks did you have? Pick a number. 10. Okay, you see they said the same amount of time. 0 hours. Did they eat the same amount of snacks? And how many hours did you study last night?
0.
How many snacks did you have?
0.
Good. You see what I mean? We got 3 people that say the same amount of time that they have the same amount of snacks. No, so they're not correlated at all, right? Now some people are like, oh, yeah, if you study a lot, you eat a lot of snacks, so you eat more snacks when you study a lot. Okay, and then you're like, well, no, because you could do a mathematical regression and be like, well, let's compare it. Let's do this mathematically. You could take a survey of all these people and be like, hey, you know what? We got 3 people already that say they study 0 hours, the same amount of time, and they eat different amounts of snacks, right? Does that make sense, everyone? No relation. That would be a correlation of 0. Okay? That was my Rocky. Remember Rocky the movie? You ever see that? What's so funny, Eli? You enjoying my class? Okay, good. All right. Anyways, if you're in the video, you need to pause and write these steps down. Okay, cool. We're going to move on here. So, quick review, positive, negative, and no correlation. Positive correlation, right, we could draw a line this way. Negative correlation, we could draw the line this way. no correlation. You can't really draw a line anywhere. You can't really find one that works. I mean, there's an infinite amount of lines we can make. Okay, so again, we can't draw like that. That doesn't work either. Okay, so those are the types of correlation. And of course, R value, we talked about this in correlation. So we're going to just move on here. Okay, so number 1, identify the line of best fit, R value, and correlation. So let's just say I was a scientist, okay? So, and you were curious, wondering, I wonder if the latitude is related to the average annual temperature, okay? So, latitude, I think that's like equator is at like 90 or not. Well, we'll have to look at it. Okay, so looking at what your average annual temperature is, depending on where you are at the Earth. If you're closer to the equator, do you predict it to be warmer or cooler? Warmer. What happens when you get closer to the poles? Cooler. But what about summertime and at the North Pole?
Cold.
It's closer to the sun though, and it's sunny all day. It's still cold, okay, right? So there's the average temperature is cooler, right? So let's do this mathematically. So what I'd like you to do right now in your notes, and I'm going to pause the video here so that people in class can do this too. You're going to write down this table because I want you to have this as a reference, and I'm going to show you how to do this and put this in a decimals. Please write all these numbers down and the title. We got latitude and average annual temperature, okay? Take a moment to do that. Okay, so what we're going to do now is use technology. We're going to plot these on Desmos. So I'm going to show you how to do it. Now that you have them in your notes, I'm going to ask you to call them out to me. Okay? So I'm going to pull up Desmos right now. Okay, and I actually have these up. So what did the x-axis represent? Remember, we're always talking about a story here. What's the story about? I was a scientist.
Oh, and then
There was 2 things on that table. What was at the top of the left column? Latitude, right? Where you're standing on the Earth, what latitude, and what is the second column?
average annual temperature.
Okay, good. It's really important. So the x-axis represents latitude, the y-axis represents average annual temperature, okay? So now I don't see any dots up here, so if I zoom out, I could find my points. And I'm clearly like seeing, hey, it looks like there's a negative relationship, okay? But we don't know how to draw a line of best fit. We could do this by hand, but it will not be precise. Now, we could also do this mathematically and take a lot of time, but that's a waste of time. We don't need to do that because we have technology to help us out. So, what we're going to do, check this out. This is the technical part. Watch up here. So, if you ever want to figure out if 2 things are correlated, and you take a survey, this is how you do it. Eyes up here on the screen. First thing you do is you make the table, then you zoom out and get the points, and then you press plus, and we're going to add an expression. Okay? And then on step 2, what was the expression? It said y1 tilde mx1 plus b. Okay, and what it's done for you, this has done a regression analysis. It did a line of best fit. Okay, so this is the perfect line that goes through all these points. Okay, all the points are the smallest average distance of all the points is the smallest, this line. Okay, so now look at this. It gives us some information. It gives us an R value right here. You see our R value, negative 0.96, and our slope is negative 1.01149, and our y-intercept is 99.6486. So I'm going to write these down on the side of my piece of paper. Can you all write these 3 things down? R value, our M, our slope, and our B. Okay, write that down. Okay, so now we can write down our line of best fit, y equals our slope of negative, what was it, negative 1.01 x plus b. Our b is 99.6. Okay, cool, that's our line of best fit. So we could see our slope is negative, right? Slope of negative 1. So that means as your latitude increases, meaning you get farther away from the equator, what happens to your temperature? It goes down 1 degree. Does that make sense? As latitude increases, the temperature goes down 1 degree. Right? Okay, what's our R value? R is equal to negative 0.09, negative 0.96. Okay, and when I look at that, that means, hey, that's, when I'm thinking about the range, right, we're thinking from -1 to +1 with 0 in the middle. Where is -0.96? It's very close to -1, right? Would you all agree with that? Which means that it's, since it's so close to -1, it has a strong indirect relationship. Okay? So we know, we can now make an assumption. Looking at this math now, we could say, hey, we're comparing latitude with average annual temperature. So as latitude increases, what do we know about it? The temperature? It decreases. Does that make sense? And we can scientifically prove, like, hey, this all connects, okay? So I got one more question. What would you predict the average annual temperature to be at 89 degrees? Talk to your neighbor really quick. What would you, remember your x-axis represents the latitude, y-axis represents average annual temperature. At 89 degrees, like latitude, 89 degrees latitude, what is the average annual temperature? Why don't you take 20 to 30 seconds to talk to your neighbor really quick and predict. What would it be?
I don't know. Simple as that. I've never made one song before.
Oh, makes sense.
Wow, thanks.
Shut up, Joe. Sorry.
Ma, you're mean to me too.
11.
Okay, so what do y'all think? How many degrees about?
11.
About 11, right? So if I look here, 89 is about here, right? Y'all see that? Right here. So if I go from 89 and look up, how many degrees is this point? Well, it's about a little less than 10. It's about 9, right? Not 11, it's about 10, right? So let's be even more precise. Since we're using technology, check this out. I'm going to go and tell Desmos to do it for me. So let's say I wanted to know, because x-axis represents latitude, right? I'm going to say, what happens when x is equal to 89, okay? And look what I've done. It created a green line, and I could see where the lines cross. At 89 degrees, how many latitude, how many degrees is the average temperature? What does it say?
9.626.
Good. You see that? You see how we can make a prediction there? Right? And we could compare that scientifically. We could say, hey, look, we could prove global warming or cooling, or if there isn't anything, we could say, hey, look at our average temperature. Now, I can't say that. I'm not a scientist, but we could actually make some mathematical sense of things and say, you know what? The average annual temperature at 89 degrees latitude, which is at the, very far away from the equator, is 9.626, right? And we could say, look at the average temperature in Antarctica. It's actually at 11 degrees. It's warmer than it should be. So what can you say? What assumption can you make? If it's supposed to be 9.6, but it's actually 11, what assumption can you make?
Cool.
Yeah, we could say that the temperature is hotter than it needs to be, okay? Okay, does that make sense? Okay, good. So, let's have you do it. Okay, so that was number 1. We have all of this information here. Let's do another one. Number 2, okay? Remember how I talked about engine size, okay? Let's say you're getting your first car. Yay, your first car. You ask all your friends, what kind of car do you have? Like, what size is the engine? And how many miles per gallon do you get? Remember that whole thing yesterday? Okay, now we're going to pretend that we're going to actually do a linear regression analysis, okay? So, you have all your data here. You have Desmos on a phone. If you have a phone or Safari or internet, you could pull it up right now. Everyone's doing it. Brian will let you get your phone. Okay, you're going to www.desmos.com if you don't have the app, and you're going to do this. I'm going to give you about 3 minutes. I expect you to work. If you are off task, I take your phone away, okay? Okay, ready, go. Okay, so line of best fit, you're supposed to put the y1 tilde mx1 plus b. So what's the equation? Y equals to what? What's our m on this example? What did m turn out to be? Look at the little box of information that popped up. What was the little?
Negative 6.2434.
Negative 6.2434. Okay, let's put negative 6.24. X plus B, what's our B? 44.26. Awesome. Okay, now looking at our slope here, it's negative, which means we could assume what? Positive or negative correlation already? Negative correlation. Now, do we know if it's strong yet? Now, what's our R value? R equals what? Negative 0.94. Okay, good. Now, is that close to negative 1, closer to 0, or positive 1? Good. So is it strong or weaker?
Strong.
It's really close. Isn't it close to negative 1? So it's really strong, but it's a strong indirect. Not direct, but strong indirect. So we put strong indirect. Okay? Now, let's put this in. What do we know about a car that has a 6.2 liter engine? Let's put X equals to 6.2. What's the answer to that?
5.5.
What was that?
5.559.
Good, 5.559. Okay, that's what we could predict, right? That's pretty bad, right? A big engine is 5.559 miles per gallon. Okay? Now we want to use it to analyze. That's our prediction. Now let's just say who has a car? Who has a nice car in here? Who wants to have a nice car? Okay, Tommy was first. Tommy has a nice car, okay? So let's just say, Tommy, what kind of car is your nice car?
BMW.
Okay, let's say Tommy has a new BMW. It's got this huge engine. It's got a 6.2 liter engine, okay? You did all of this work, and your math problem turned out that Tommy should get 5.59 miles per gallon, okay? Now I asked Tommy, how many miles per gallon do you get, Tommy? And Tommy says, actually, I get 18 miles per gallon. Okay? What does that tell you about his car?
It's a good car. It's an outlier.
It's an outlier. It should be 5.59, but is it 5.59? No, it's not. It is like way better. So what do we know about Tommy's engine in his car? It's a good car, right? Does that make sense? Now let's just say we were looking up a different engine. Let's say it was like a 2-liter engine and you're supposed to get like 33 miles per gallon, okay? And let's say you're going to buy a used car and it's like, oh, this thing should get like 33 miles per gallon. So then you get to the guy or girl and you're like, how many miles per gallon does he get? And the guy's like, I don't know. It's like, it's pretty bad right now. It's like 10 miles a gallon. It's been like that since I ever got it. What do you know about the car? Something's wrong with it, right? Does that make sense? It should be getting 33, but it's only getting 10, right? Does that make sense? It means you have some major engine problems. So would you buy the car? No. Okay? Do you see how you have these little analysis here? Okay, good. So that is why we do that. And we're going to go and end the lesson here. So what I'd like you to do now is you're going to be working on your workbook, page 65. Only on number 5. We're done with the other ones. You should be done with numbers 1 through 5 at the end of the period. And then you could also work on AMs. That concludes the lesson. Thank you.